Okay, today we're going to be talking about the properties of logarithms. This is going to help us with solving logarithms, hopefully here in the next day or two when we get to those lessons. So we're going to kick off right away here. So first of all, the product property with logs, we can go and say that if you have a log base b of m times n, we can actually split up the logs like this right here. We're going to write log of base b of m, and then plus log base b of n right there. So whenever we are multiplying two things that we're doing logs of, you can split it up with addition of two separate logs. Okay, the quotient property, kind of the same idea except with addition. Instead of addition, we'll do subtraction. So we'll go log base b of n right there. So we'll subtract the two. And whatever's in the numerator comes first. Whatever's in the denominator needs to have a negative out in front. Okay, and then the last one that we're going to do here is the power property. So if you have a m and then it's raised to an n, we can write n times log base b of n right there. So basically, I like to usually draw like a little arrow. That exponent's going to come out here to the front right there. Okay, so before we do these problems right here, I'm actually going to jump into expanding and condensing logs. So what that basically means is we're going to go and take a single log and then we're going to write it as a couple of separate logs. So like with this one here, here's what I mean. So we'll say log base 5, and since you have three things you're multiplying, 3, x, and y, you're going to have three separate logs. We're going to write log base 5 of 3 plus log base 5 of x, and then plus log base 5 of y. Okay, and then that is all you can do as far as expanding. So you're just writing these as multiple logs. All right, and this hopefully will help us really, hone in our skills of doing our log stuff. All right, now with this next one here, you have two things you're multiplying, but notice this x cubed here has an exponent. So first step, we're going to split it up as log base 6 of 6, and then plus log base 6 of x cubed. Okay, the next step here, we're going to take this exponent right here, and then we're going to write it out in front of the log. So we'll write 3 times log base 6 of x right there. And some people, you'll see them where they just write 3 log like that, and that's the same thing. Now this one's actually kind of a special case here. Since we have log base 6 of 6, we can actually simplify that. We said whenever that happens, our log property says that simplifies down to 1. So to get full credit on something like this here, this would be 1 plus 3 log 6 of x right there. Now most of you guys will get pretty close to full credit if you left it as log base 6 of 6, but yeah, simplify that down to 1 if possible. That's only if the base is the exact same thing as the number. Most of the times that won't happen. Okay, now when you have a division one, that means you need to be subtracting all of this stuff. And here's how I approach it. I write this as log base 7 of 3, and then plus, and that's up there in the exponent, or up there in the numerator as well, so we'll go log base 7 of x squared, and then you're going to go minus log base 7 of 5. And then since the y cubed is also in the denominator, we're going to put a minus log base 7 of y cubed. So you got a bunch of stuff going on right there. All right, so make sure both the logs of the stuff in the denominator, make sure both of those have negatives out in front. That's the big thing there. All right, and then the last step we can do is take care of these exponents and bring them out here to the front. So we're going to write this as log base 7 of 3, and then plus 2 log base 7 of x, and then minus log base 7 of 5, and then minus 3 log base 7 of y. And then that is it there. So that is a couple of examples there of expanding logs into multiple logs. And then sometimes they're going to give us problems where we condense into a single log. So every single one of these problems here, we're going to be able to write as a single log right here. So first of all, look at all the numbers that you have here. So you have log base 8, or I'm sorry, log of 8, log of x, and log of y. All right, now since there's no base written, it's considered to be a common log. It's implied that it has a base of 10. You don't necessarily need to write that. But as far as writing the product of these here, since you have 8 and then x right there, and they're both positive, we're going to write this as 8 times x. And then since we have a negative right here for the log y, that's actually going to be in the bottom of a fraction. So you actually have a little bit of multiplication and division on this one right here. So this will be log, and then I guess base 10 if you want to say it, and then log of 8x, and then over y right there. So write it as a single log. Okay. Sometimes you'll get these ones where you got some numbers out here in front, some coefficients. So if we're going the other way, we write those as exponents. So that's the very first thing I'm going to do. So this will be log base 2 of x squared. And then this next one, don't worry about the negative. Keep it as negative log for a second. Log base 2 of, I guess, 5 and then raised to 3. And then we'll go ahead and, since it has a minus here, we'll write it as a fraction. Log base 2 of x squared over, I guess, 5 cubed. And by the way, 5 cubed, we can actually go ahead and write that as 125, since that simplifies. And then these technically are the same thing. This is your final answer right there. Okay, the next big one here, let's see. So we got another coefficient out in front, so that's going to come up here as a power. Notice these are all natural logs. So this first one here, I'm going to write natural log of 5 squared. And then I guess we got minus natural log of 10. Okay, and then since you got a plus right here implied in front of the first log and then in front of the second log right there, those are going to be multiplied together. So that's going to be natural log of 8 times 5 squared. All right, and then we're going to divide all of that. Since there's a minus out in front of this log, we're going to divide all of that by 10 right there. All right, and then I guess we can go and start to simplify that. 8 times 5 squared. 5 squared, first of all, is 25, so I think that should be 200 right there, and then over 10, so then that actually simplifies the log, or natural log of 20 right there. So sometimes with the condensing problems, you want to actually go and simplify some of the numbers if they give them to you. No, only when it's possible, though. So there you go, natural log of 20. Okay, last one right here, condense this crazy log equation. It's got a lot of things going on. All of them have coefficients. So we're going to have to bring out, I guess, this 5 right here. We're going to have to bring up the 7 and then the 4 as well. So first step I'm going to write is log base 4 of 2 to the 5th. We're going to go log base 4 of x to the 7th. And then keep the minus just for a second here, and we'll go log base 4 of y to the 4th. Okay, and then we'll go ahead and, since there's implied positive right here, these two are being multiplied, all of the stuff in the parentheses, I guess. And then this minus log right here, that'll be in the denominator. So we're going to have, I guess, log base 4 of 2 to the 5th power. And then I guess times x to the 7th, and then divided by y to the 4th. And then to get full credit, we can actually simplify 2 to the 5th. I believe that's 32. So then we'll call this log base 4 of 32, and then I guess we'll just call it 32x to the 7th, and then all over y to the 4th. And then that is it right there. All right. So that's expanding and condensing your logarithms down. So we're going to use that same idea here on these problems right here. And I wanted to show you guys those first just so you kind of grasp these a little bit better here. So now sometimes these problems can vary a little bit. Sometimes they'll give us decimal values for logs here, and they want us to show with expanding and condensing, finding the decimal values that these are equal to. Now, sometimes I've seen some math textbooks actually give you fake decimal values that actually aren't this log number here, and that's more to just show that you understand the process of what you're doing versus actually getting the right answer. But what I went and did here, I went and changed these here to the actual decimals, but I changed them to where they weren't, 3 or 4 digits long, so we could do it without a calculator to like really hone in like what the big ideas here are. So sometimes you'll get problems like these here. It says log base 4 of 21, and somehow we need to use log base 4 of 3 and log base 4 of 7 to evaluate. And what that means here, what we can do is take this log base 4 of 21 and think, okay, what two numbers, probably some of these numbers that they gave us, can I do and add, subtract, multiply, divide to get 21. So in this case, I can actually write this as 3 times 7 right here. Log base 4 of 3 times 7. That's the exact same thing as 21. So with that case, then we can actually split it up using our properties, and we say this is log base 4 of 3 plus log base 4 of 7. And then since we have those decimals up there, we can actually replace both of these decimals here. I can replace this first decimal to 0.8, and then I can replace this second decimal here to 1.4. And then we can actually evaluate and simplify that. So apparently when we go and add up these logs right here, you got 0.8 plus 1.4, so I guess that'll add up to 2.2 in this case. And that's an approximate answer. That's not actual an equal sign right there. It should be approximately 2.2. Now, sometimes they might give you a couple of longer decimals there, so you just take your long decimals and then add them up or subtract them, depending on what they are. So in this case, just 1 decimal to the 10th. So kind of the same idea here on B. Now they actually gave us a number we can work with here, 3 over 7. So we can do this pretty easy here. We're just going to write log base 4 of 3, and then since it's division, we'll subtract these decimals here. We'll go log base 4 of 7, I guess. Okay, and then from here we can go and use those two decimals that we had. So we had 0.8, and then we had 1.4. All right, and then once you subtract, I think you get negative 0.6, and then that should be your answer. Okay. Next example, you got log base 4 of 49. So we're going to do log base 4. So actually with this one here, we can't really do 49. We can't say it's like 3 times 7. That's not going to get us our answer. But it's actually, you can do two things. You can either say it's 7 times 7, or you can say it's 7 squared, which is actually the approach I'm going to do here. So I'm going to write this log base 4 of 49 is the same thing as 7 squared. And then with this exponent right here, I'm going to bring it out here in front. So this is 2 times log base 4 of 7. So once again, we're changing 49. That's the same exact thing as 7 squared. So numerically, that didn't change anything. And then now we're bringing the 2 out in front of the log. So then we will write this as 2 times the log base 4 of 7, which is this decimal here. So we'll say 2 times the 2 times the decimal 1.4. All right, and then if you do that, I think you get 2.8. And then that'll be your decimal. Okay, couple more here. Let's see what we got on this one here. Oh yeah, this one's kind of a special case here because notice it's log base 4 of 16. In 16, we can't really divide by anything. We can't do 16 divided by 3 and get any of these other numbers, or 16 divided by 7 or anything like that. Can't even do times or anything right there. So this one's kind of a weird one. But this one actually here, since you have 16, we can actually write that as a base of 4. We can write this as log base 4 of, I guess, 4 squared right here. 16 is the exact same thing as 4 squared. And then since you have a log with a base of the same exact number, we can say these cancel out to just 2. So this will be exactly 2 on this one. This is actually equal here. That's not a decimal approximation. That is 2 right there. So every now and then they'll give you numbers that don't even use log base 4 of 3 or log base 4 of 7. So just kind of watch out there on those. Okay, now this last one's kind of doing a bunch of things. You got division, obviously. And then also with this here, I'm going to write this 9 right there. I'm going to write that as 3 squared And then in 49, I'm going to write as 7 squared. So we're going to go log base 4 of 3 squared and 7 squared. That's the same exact thing as 9 and 49. And then what I'm going to do is write it as subtraction. Log base 4 of 3 squared minus log base 4 of 7 squared. Okay, and then from here, put your exponents out in front. So we're, doing your expansion stuff. So 2 times log base 4 of 3, and then minus 2 times log base 4 of 7. And then now we can replace them with those decimals. So 2 times 0.8, and then minus 2 times, I think it was 1.4. And then, yeah, kind of running out of room here. I guess I'll go write it over here. So 2 times 0.8 will be, I guess, 1.6. And then 2 times 1.4, that'll be 2.8. And then I guess we will subtract those. So subtraction, what does that get us? That gets us 1.2, or actually, I'm sorry, negative 1.2. And then that would be your answer there. So there you go. And that's about as hard as those types of problems get. All right, the last thing here, it's kind of something we don't use as much anymore just because our calculators can do logs pretty easy. But actually, I guess when I was in high school and doing logs, we didn't have a log base button. Like, if we wanted to type log base, 3 of 8, you'd hit, the log button over here. You'd hit math, and then you'd scroll down until you find log base, B, or whatever. But we have this one property, it's called the change of base property. And here's what it means here. So if you take log base 3 of 8, you can actually write this as log base 8, or I'm sorry, log base 10 of 8 right here over log base 10 of 3, which we would just type in our calculator log 8 over log 3. And it's actually much quicker to do this method right here as opposed to just doing log base 3 of 8 in our calculator. So let me show you what I'm talking about here. So if I wanted to go and do the change of base property here, all I need to do is log of 8 and then divided by log of 3. And then instead of scrolling through that table or scrolling through math and then looking for that specific button, you can just kind of quickly get your answer there. Now you'll get the same exact thing if you hit math and then you scroll down to log base. So hopefully this will be the same. So we had base 3 of 8, and notice that gives us the same exact decimal. So I think the way the tests are, or at least our test is worded, is it's going to say use the change of base formula. Show it, show the answer using the change of base formula. So like on this one here, we're going to say this is log 24 over log 6. And then we'll get that decimal. So now as far as which way you type it into the calculator, it doesn't really matter. So log 24 and then log of 6. And then that comes out to approximately 1.774. And let's see here. They didn't ask us to do any rounding, so we'll just write it as 1.774. Doesn't matter. Oh, I guess I forgot to write the answer to the last one there. Let's get that. That was 1.89. Was that 3? Okay, so just the big thing I would emphasize, especially for your test coming up here, is make sure you show these steps here, the change of base steps. Okay, last one here, I guess we'll write this as log 9 divided by log 26. Okay, so let's take our calculators to do that. Log 9, and then, calculator, I'm trying to type it in here. Log 9, and then divided by log 26. And then, there we go. Apparently that decimal there, 0.674. And there's your answer there. So as long as you write this stuff down here, that'll be enough work to show your change of base. And I believe that is it here for today. Yep.